All right. So speaking about interconversion, the basics of it you guys already know. You must have come across these processes and these concepts pehle. So let's get it over with. We have three states of matter we'll be looking at: solid, then we have liquid, and we have gas. If you want to convert solid to liquid, what is that process called?
Melting.
Melting, as absolutely. Scientifically also, like a lot of cases you use the word melting only, but depending on the context, some of the times in scientific literature you also use the word fusion. Okay. Like latent heat of fusion, fusion point. So if you come across the word fusion, it is nothing but melting. Both mean the same things. Same meaning, just different words. And what is the conversion from liquid to gas?
Vaporization.
Vaporization, absolutely. Alternate word for vaporization, like everyday term में क्या use करते?
Evaporation.
Boiling.
Yes. So whenever you consider liquid to gas, go for like a default of boiling. Evaporation may be liquid is getting converted to gas, but it's like a special case. Like it happens only, like it's only a surface phenomenon. Like it's a very special case of conversion. So hamesha when we talk about conversion of matter, go for vaporization or boiling. Okay. Next, we look at the reverse process. Isi ka. Liquid, when it is getting converted to solid, what is it called?
What about sublimation? The gas to solid.
Yeah, we'll do that. I'm just going over the ones you're familiar with. Then we'll talk about sublimation.
Ma'am, this is freezing, ma'am. Liquid to solid.
Freezing, yes. And gas to liquid?
Condensation.
Condensation, yes. Who said it? Jayad. Nice. Good job. So all of these you're familiar with. Now coming, like closing the other side of the triangle, converting solid to gas. What is the process of conversion of solid to gas? Any idea? Have you guys come across this before?
I was going to condensation, but then you have to freeze it also.
No, yeah, condensation is gas to liquid. ये process हो रहा है solid से directly gas बन रहा है. Like it is not going to liquid. See, so when it directly turns from solid to gas.
It's sublimation, right?
Yes, this is called sublimation. This must be new. Like, have you guys come across this before?
No.
Yes, ma'am. Yes, ma'am. In 4th grade, we were taught this.
Oh, okay. Some of you have, some of you haven't. Okay. So sublimation is the process of conversion from solid to gas without turning into liquid. So abhi ke liye just, you can note this down as a table or something. I'll give you guys time to note down the definitions सारे processes के. Okay. And reverse process is ka, when it is turning from gas to solid. So gas particles hai, without liquefying, directly solid में settle हो रहे हैं. So that process is called deposition. Yeah. So it comes, you can think of the word deposit. So deposit का मतलब क्या है? Have you guys heard of the word deposit?
Like putting something somewhere.
Putting something.
Like deposit cash in a bank.
There you go. So like you can imagine gas हवा से it is getting deposited into a solid. Okay. Solid gas, like sublimation, all of you have seen it happen in real life, although you may not have known कि अच्छा ये
Camphor.
हो रहा है. So can you think of any examples where you might have
Is
come?
camphor one?
Camphor,
Naphthalene balls.
naphthalene balls, yes. So naphthalene balls, moth balls, ये सारी solid है, but after a few days they disappear off. Are they just like randomly vanishing into air?
No, they kind of like evaporating and turning to gas.
Yeah, they're turning into gas, and क्योंकि solid से gas हो रहा है, we call it sublimation. In that case, you don't call it evaporation क्योंकि liquid touch ही नहीं हो रहा है. It's direct solid to gas. Okay, you don't find puddle of like naphthalene balls or a puddle of camphor, right? Direct gas, it's sublimation. Mr. reverse process is deposition. Have you guys heard of something called dry ice?
Yeah.
Yes.
Oh, what is dry ice?
Can I know?
It's carbon dioxide.
Carbon dioxide. Where have you guys heard of it? Where have you seen it?
In
Usually, I have seen it in fish markets.
Yes, absolutely. I don't know if they still do it, but some store like 3-4 years ago, जब ice cream का home delivery मंगाते हो ना, so they like ice cream needs to be cold, so they used to deliver it with dry ice to keep it cold. But it's called dry ice, but it is nothing to do with water. So this is basically solid carbon dioxide, solid form of carbon dioxide. CO2 is a gas normally room temperature pe, but they cool it to like such an extreme temperature that it turns into a solid. So once you get it out of its cooling state, like once you put it at room temperature, because room temperature पे gas होना चाहता है, तो this basically sublimates into carbon dioxide gas. Okay, so once you guys are done writing, we'll look at some videos. The melting and vaporization, so you see it every day. Look at sublimation wale videos. Okay. Sahil, Anvesha and Neil, you guys done? Are you noting?
Yes.
Okay. Neil is
Yes, I'm done as well.
okay. Roshmit is writing. Kushagra, are you writing or are you finished?
I'm done.
Done. Okay. Jaydeep is still writing. Okay. ठीक है. मैथ का कोई क्लासेस स्टार्ट किया क्या तुम लोगों का?
What?
Have you guys started any math chapters?
Yes, ma'am.
We
have
finished with one.
Ma'am, we have completed one. We have completed one in school,
Which
and
one?
we have started with the second one. Probability we completed, and now we are going to do the second one.
She started with probability. Okay. वो तो
We
एक,
are done with probability, ma'am. Now we are doing polynomials.
oh, they started with polynomials in your class. ठीक है. So I wanted to schedule a math session, so we'll do it based on that.
Yes, ma'am. Because we have not had any TWA math sessions since beginning.
We just had 1 week, like 3 classes till now, no? This week we'll have a math class. Cool. I think everybody's done, right?
Yeah.
Okay. Video.
Done.
Cool. So, we'll look at carbon dioxide ka sublimation first. So this is what solid carbon dioxide looks like. Kind of looks like ice, but it's not ice made of water. That's why it's called dry ice.
Miss, it's on mute.
Yeah.
The video's on mute.
Yeah. I mean, they're just talking about this. You can see it's not melting. Like, यहाँ से directly you can see the gas. solid से direct gas आ रहा है, there is no liquid droplets or anything over it. That is sublimation. So now you can see they put the copper coin. I'll just pause it here. Copper is a metal, and metals are good conductors of heat. So because they can transfer heat directly, either they can absorb or give heat direct. Heat can pass easily through copper. So the copper basically sublimates the carbon dioxide because it's at a lower temperature. It absorbs all the heat from copper. And as the copper is cooling down, water vapor starts depositing as solid ice on the copper. So that's what you'll observe here.
One question.
Yeah.
Do we have liquid carbon dioxide at all?
You do. Not at room temperature, not at atmospheric pressure. You need to change the conditions a little bit, but absolutely. Every form of matter you can make it in the form of solid, liquid, and gas. So do you see icicles growing here? So that's again vapor directly to solid. That's deposition. That is really weird music. Music. Yeah. So dry ice, solid carbon dioxide sublimates and water vapor is depositing. So water vapor, naam mein hi hai, its vapor gaseous state is directly getting converted into solid ice. Okay, so this is one example of it. It's not unique to only these materials. You've seen naphthalene balls and camphor are examples you guys have given. Iodine also, because it's a colored substance, you can see it happening very beautifully. So this is another thing.
This is elemental iodine. It's a dark black bluish solid.
Have you guys come across iodine before? Like, have you done any experiment with it or read about it? Have you heard of iodine?
We had used iodine once before in grade 6.
Test for starch, blue-black color, yeah.
You know, I've been in the science lab for a long time. You know,
Yeah, 2-3 years, no? This year, you guys will get to do some laboratory experiments.
this year our teacher has asked us to do experiments. We have to do it on our own.
Yeah, 9th and 10th. But it's not like they're gonna leave you. You'll have like people telling.
No, it's like a project. We have to do it on our own and to show it to them.
Ah, okay. Projects.
At room temperature.
Generally, it starts for us in grade 7, but thanks to coronavirus, we did not, we actually could not go.
Oh, halogens. When we heat up the iodine, it's going to turn directly from a solid into a gas. The iodine vapor has a beautiful purplish color. This process is called sublimation,
There you go.
turning directly from solid to a gas. Now we place a cold flask over top of the vapor. The warm vapor will cool off on the cold glass, and the gas will turn directly into a solid. This process is called deposition. In this case, we're seeing the deposition of iodine onto the cold glass surface, where we would say that iodine is depositing onto the cold glass.
So again, gas directly as solid. There's no liquid dripping from it. So there's deposition.
We can't do this experiment in our science classroom because the iodine gas would be harmful to us.
Yeah, that's sublimation and deposition.
Is this crystal like really rare or something?
Sorry, what is this crystal?
Rare or something, very expensive if you buy it. Is
It
it
is
value like
really not
diamonds?
rare. Iodine is like pretty common, extremely common. You'll find it in
No,
all
but
the
these
hospitals.
crystals.
I think, right? It's like very affordable.
It would be. Let's take
Can
a
you use these crystals in like how you make a diamond ring or diamond necklace? Can you make stuff out of this? Like, can you use the crystal for that stuff, or is it harmful?
No, you can't, unfortunately, because iodine is going to react with other substances, air, like carbon
But it
dioxide.
looks so cool, right?
Yeah. It looks cool, yes, but it'll react, which is why you don't find rings like jewelry made of iodine. It's not long lasting. There you go. So that's sublimation and deposition. Let's not have this ad right now. Okay. So let's get back to this. We'll quickly revise all the definitions and write down the definitions. Or do one thing, like don't note down the definitions now. End of the class, I'll tell you guys what all to write it down, and then submit your notes. Okay.
Can we please write it now? Meaning it becomes like unless it like it consumes less time and it's faster and like we remember.
Yeah,
it.
but like we'll be wasting the classroom time, right? Like
Okay,
that
fine.
will
Then
be
let,
writing in
okay, then fine. We'll write it later. We'll write it.
Yeah. End of the class. Once it's done, just do that. Okay, so what exactly, like, okay, so these are the terms related to the process. Now, how do you change from solid to liquid? Like, what do you do in order to melt something?
Heat it up.
We heat it.
There you go. You heat it up. Now, why does heat, like when you say, basically you're changing the temperature.
I had asked the teacher the same question, and she said that when we're heating, we take ice or something, when we heat it, it melts into liquid. So what is happening is the intermolecular forces which are holding it together, the energy is weakening that force. So it's like changing
Absolutely.
its shape.
That is exactly what is taking place. Okay, so when you're changing the temperature, when you're increasing the temperature, what you're essentially doing is you're adding heat energy. Okay, so the example what we took is solid to liquid, right? So let's look at the particles in a solid versus particles in a liquid. Now, like this, we discussed it earlier last class itself. What is the difference in particle arrangement between solid and liquid?
The distance between each particles.
Distance, no. Liquid, maybe they are close by together, but the main thing
But
is,
solid, they're like tightly packed.
yes, they
liquid has less rigidity.
correct. So they are looser than solids. Solids are extremely rigid. अगर एक stack में किया तो they can't move. That's the only place they can be. Think of when you're sitting in a classroom and a class is going on. In the case of liquid, they're close by together, but they're like free to flow and move around. So between solid and liquid, ये moving around के लिए you need extra energy. Right? Again, last class I told you guys what kinetic energy is. अगर movement हो रहा है मतलब move करने के लिए energy चाहिए. So that energy is what you are providing when you're heating a substance. That is why on heating, a solid will always transform into a liquid and liquid will transform into a gas. Or in some cases, solid directly to gas. Like you're giving the heat energy so that the molecules can increase their kinetic energy and then they end up moving. Movement matlab going to be either a liquid or a gas depending on how much heat energy you give. Yeah, so that's basically what is happening when you change the temperature. Okay, so you like obviously you can't see. So here's like a thing that will help you visualize kya ho raha hai. So this is like a bowl of solid ice hai. Ice is melting into water. So in the particle, see, like one important thing I want you guys to observe is, even though solid may particles are tightly packed and they don't have place to move around, they still have some movement within their places. Particles are always moving. Universe में ऐसा हो ही नहीं सकता है कि any particle is stationary. So whatever state of matter they are in, they will always move. At least a tiny bit of movement is going to be there. You can see it like vibrating over here.
What about in B condensate? over there तो इतना ये था कि nucleus overlaps.
Sorry, what was that, Neil?
Don't particles in B condensate remain stable, meaning they are so amazingly tight?
Yeah, but there's still a tiny bit of movement. Like it is obviously you can't see the molecules with your naked eye, but it is practically impossible to have completely perfectly stationary particles. Tiny bit of movement is always going to be there. There's a reason for that. It's like you know, once you get into the gas laws and everything, you get it better. But yeah, so this is the conversion into liquid. So I'll just like show it once again. Solid, you can see they're still close by to each other, but now they are free to move around. So that is like the main difference between solid and liquid. Now it's like melted into liquid. And when you convert it into gas, like as you keep heating it, so this experiment is a setup to show that in order for conversion between solid to liquid to happen, the energy will be absorbed. The temperature drops because it absorbs that heat energy. अभी पूरा liquid है.
I had heard of Boyle's law, meaning is that a part of the gas laws?
Can you repeat that, Neil?
I had heard of the gas laws, meaning Boyle's law. ऐसा कुछ तो सुना था. Is that a part of the gas laws?
Yeah. We have Boyle's law, Charles' law. All of these are scientists who figured out those results.
Have you studied these laws?
Yes, of course. They form the basics. Like when you go to grade 11, you'll come across that. You take up science. So liquid here, they're close by, but they're able to move. But once they get enough energy to move, they start escaping out into the air. Like now you can see the gap between each of these particles increases a lot. So that basically here they're in gaseous state. So this is what happens when water is boiling, okay, at the particle level. That's essentially what is happening. Okay. Now, how is this interconversion? Like, how is heat energy related to interconversion? As Sahil said, heat energy is required to overcome the forces of attraction between these particles. Absolutely. But what is the connection? Like, how does heat energy enable them to get over this thing?
You had earlier said that every solid shape, like every type of solid follows this freezing, right? So does that include the types of solids?
What? Which solids?
Like solid is there, like if it melts, it's melting. So like almost every object can melt. Like, there are a few exceptions.
No. Everything
Yeah,
can.
actually,
You just
almost
need to have the right
nothing can
conditions.
melt. Yeah. But
Everything
does that
can
like the other types of solid, does this also like follow up with those things?
What type of solid are you talking about?
There are like two categories of solid, no?
Which two?
Crystalline and one more.
You're talking about crystal and amorphous. Yeah.
So does this follow that?
Yeah, absolutely. Like again, it like the conditions in which it happens will differ, but it every solid, you know, once the particles get loose and you know, once they start flowing around, we call that liquid state. And once those particles ke beach mein, if the distance increases so much and they start zooming around, we call that gaseous state. Yeah, absolutely. Yeah, Lisa, you had raised your hand.
I wanted to say about the heat thing. I I'm
Hmm.
not sure if this is correct, but I think it's because gases expand fastest on with heating. So the spaces between the molecules.
Yes, it's the the connection you figured out is correct, but it's the other way around. So like when you heat, the energy, the particles have so much energy, they start moving a lot faster, which the effect of it, you feel like, okay, the gas is expanding.
Oh, okay.
Yeah, Jaydeep.
Ma'am, so I guess the particles vibrate, which creates some more energy.
Yes,
And-
very close there. Yes. So heat energy, when we talk about heat energy, it is directly related, or basically what is heat energy? It is the total kinetic energy of all particles. So heat energy you're aware of. Basically heat energy, how you measure it with the help of temperature, tells you the hotness or coldness. Something is hot, temperature is greater. Something is cold, temperature is lesser. So what you see as temperature and what you see as heat energy is essentially, it is the total of the kinetic energy of all the particles that are there in the object. Like if the phone is overheated, if I feel that the phone is hot, मतलब यहाँ पे इसके जो भी particles है, they are vibrating really 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 fast. मतलब उनके kinetic energy is really high, which is what I am feeling as hotness. Okay. So heat energy is basically the total of all kinetic energy of all the particles. So if you're supplying heat energy by heating up the solid, you're indirectly giving, like, all this heat energy is getting converted into the kinetic energy of the particles. And last class we studied that only, right? So as the like solid का एक kinetic energy है, liquid के kinetic energy is greater than in the solid. So solid turn into liquid. That's what we observe as solid turning into liquid. So that's how heat energy is related to the change in state. So you're giving it a lot of kinetic energy. Eventually it's gonna move enough to overcome those forces of attraction, and then change in state happens. Okay. Okay, I see some of you like noting this down. Once you're done, we'll go to the next part. Sahil, Anvesha, you guys okay? Are you guys there?
Yeah,
Oh yeah. I'm still writing.
What happened? Why are your videos off?
I was having Wi-Fi issues actually. I wasn't able to hear until I turned off my video.
Okay.
yes.
Ma'am had already written this when you were explaining, so I was just checking about the Boyle's law.
Oh, okay. That relates with pressure volume. It is related to change in state. And
Yes, inverse. So it says that pressure is inversely pressure exerted by a gas is inversely proportional to its volume.
yes. It is not, it's completely tangential, Neil. Like I would suggest you saw it, keep it aside, because it'll be very distracting and it'll get confusing because it's not related to change.
Okay, and do it after class.
Yeah. Again, as the state like name suggests, they are gas laws. They're specific to gases only. They don't apply to solids and liquids. Right. Deep's writing, Eliza is writing, Roshmit's writing. Okay. Is also writing. So in this chapter, till what point have you guys reached? Have you completed the chapter, schoolmate?
No, in school we just started with kinetic energy.
Started
We have covered.
Kinetic energy.
kinetic energy. Okay.
Ma'am, we have reached till.
Actually, we did not do much on it. Today's class was mainly it went in an activity, and also we had to draw a diagram of measuring temperature and that.
Oh, I'm going to do that
Oh,
only.
which one's that?
So you guys will catch on it. Yeah.
But
Which
just
one is
one question, meaning, will you that Y Academy book which we have been given, when will you teach from that, or when, and when will the tests and everything be taken? Meaning, you understand that some tests will be taken and we have to
Yeah.
solve the workbook and everything.
Yeah. So we literally just started, right? So once I finish, at least in one subject, when you guys finish like a major chunk. Abhi chemistry ka we've had 2 classes. We'll be finishing up to like 80-90% of the chapter today. 340. Okay. So this weekend, I think bio class is also scheduled, right? So in dono chapters pe we'll have like
This week.
a diagnostic test for you guys.
I'm Miss When are we gonna have a maths class? Because we've not had a maths class today.
We will. Is it there? If not this week, definitely next week. Once one chapter in these 3 subjects is done, we'll start off with math. Oh, that reminds me. What do you guys start off in math? Polynomials.
Oh yeah, we finished probability and now we started polynomials.
Okay, that is correct. Okay, probability.
But can we do it according to the order? Meaning, school is just doing random topics because they have not received proper instructions from the board as to
Or they're
what
just doing
topics.
the topics which are easy
So they're
and
just
easy
doing
to
random
revise.
topics. So can we go according to a particular order? Because like the school is just doing some random topics. So
Mister,
So
you have to follow what the school
the
is teaching
logic,
you.
yeah. Like I see, if I pick up real numbers or something, then you will have the work from your school, like you'll need to focus on that. And yeah, यहाँ पे अगर completely different track चल रहा है, the workload on you guys will be a lot, and it'll be very very scattered. थोड़ा ये, थोड़ा ये. So we'll follow along with the school, and abhi it may seem random, but what your school is doing is they also following a certain logic. So they're finishing off the easier ones, and like probability
Yeah,
is
and then
very
leaving us to do the tough one.
Sure.
in the
like
end.
I did not.
I
Yeah,
missed,
it was like
just
probability
give
is
us 5
nothing.
minutes.
Everybody could easily do it.
exactly,
Even
which
like
is
that.
why they finished it off and like kept it aside. Now they'll start with proper algebra, which is polynomial.
Even the
Just
polynomials,
give us
they are
5
going at
minutes
a very
about it.
quadratic and biquadratic, very simple way.
For polynomial starting is simple, but once you reach identities, you'll be using those identities in.
There are we have. I think we have covered 7 identities.
I don't remember the exact number, but you have like squares related identities and then cubes.
I remember doing square and cube related identities. I think.
Yeah. Anyway, we'll do that when we look at polynomial.
Get there.
Yeah. Now, yeah, focus on this. Everybody's done. Yeah. So you guys already did that activity, no? So that's what we'll be. I'm going to start right now. सबके classes में हो गए क्या, or is it just one section? The temperature.
Which activity?
Plotting the temperature time graph.
किसी के हमारे क्लास में नहीं हुआ है. Meaning 4 classes it's not yet covered.
Okay.
Should I get a graph book?
No, not necessary. Motion में, have you guys, like, how much have you done in motion in TWA class or in school?
Actually, in school we have covered everything of motion and everything, meaning many things of motion. We have not yet teaching laws of motion, but we have done the graph work and everything. At least we did that
You guys
today.
have your VT
Because
graph, ST graph, displacement time, velocity time, वो सब covered है.
not all those many graphs. We are just doing some basic displacement and distance graphs.
Okay.
Because we only have 2
Displacement time.
periods, and we are going to we have very less periods, and search engine like taking presentations and everything. So like he told me to make a presentation totally off topic on so like that we are losing a lot of time in school physics, so we should easily be able to catch up in over here.
ठीक है. Cool. Now coming back to this temperature time graph, it is very very self-explanatory. We are going to be plotting. Okay, here's the premise. Okay, so imagine you take a beaker of ice. Okay, so ice, you guys know, are you familiar with the melting point of water, boiling point of water? Yes, no? Answer. Like at what
Yeah,
temperature?
we are familiar. We are very familiar.
So at what temperature is ice melting into water?
Anjan, ice melts into water at this 0 degrees Celsius.
0 degrees Celsius. And at what temperature does water boil off?
100 degrees Celsius.
100.
100 degrees Celsius. So these basics you should know, then this will make sense. Okay. Actually, before doing this, yeah, let's get familiar with these terms also quickly. And let's see, it makes sense. Okay, terms involved in change of state. Okay, fusion, we have studied. Fusion is basically melting, process of conversion of matter from solid to liquid. Usko bolte hai fusion, which you know as melting. Abhi, fusion does not happen randomly. It happens only at one particular temperature. Once that object hits that temperature, तभी अगर solid है तो वो melt होके liquid बनेगा. So that temperature, like definite temperature at which a solid starts melting, is called melting point. So abhi aap, you know, do you know at what temperature your freezer is at? Fridge mein?
-14.
-14. Okay, so I've come up, yeah. So in the freezer, it is below zero. It goes at -14 degrees Celsius. In the refrigerator, it is maintained at 4 degrees Celsius. Because, you know, research karke they figured out that that's the ideal temperature at which food is supposed to be stored. So that, you know, bacteria and all won't grow, but the food will still remain unaffected. So freezer may, because it is below 0 degrees Celsius, it is going to be frozen solid into ice. But once you bring that out, uska, like obviously agar room temperature is at 27-28 degrees Celsius, so -14 se slowly it'll start increasing. Once it hits zero, ice will start melting into water. So that's the melting point. Boiling point, same thing. Process of conversion is boiling, or also called vaporization. And the temperature at which it happens, that is called boiling point. The point at which boiling takes place. Self-explanatory. These are the main things. Sublimation, we already discussed. Solid directly into gas without passing through the liquid state. Vaporization, liquid to gaseous state. Freezing and freezing point, same as melting point, but the process is reverse. Melt होना मतलब solid से liquid बन रहा है. Freeze होना मतलब liquid से solid बन रहा है. Another thing, freezing point and melting point are the, like, numerical value is the exact same thing. So अगर ice, पानी, water का melting point is 0 degrees Celsius, its freezing point is also 0 degrees Celsius only. The only difference between freezing point, melting point is क्या हो रहा है उस temperature पे. अगर solid to liquid melt हो रहा है मतलब you refer to it as the melting point. उल्टा हो रहा है, freeze हो रहा है मतलब you refer to it as the freezing point. But numerically it's the same thing. That's like the borderline temperature. You can think of it like that. Okay. Condensation, this you guys know, conversion of gas to liquid. Now, before we talk about latent heat, now we'll start looking, let's look at that particular experiment I was talking about, temperature time graph. Okay, so iske liye, if you have an idea of what is melting point, boiling point, it will help. So initially, let's say I took ice, let's say iska initial temperature is -5 degrees Celsius. Then I placed it and let's say I started heating it. Let's stand here. This is the very rough diagram of the Bunsen burner. And I'm going to start heating it. And this is going to be undisturbed. Throughout the process, I'll keep heating this ice. Now, I'm going to draw a graph. Graph you guys are all familiar with. X-axis hota hai, Y-axis hota hai.
But
Now just look at it now. I'll give you guys time to like notice down and like draw it. Okay. This you don't need to like, graph is the main thing. Your understanding of graph is what is required. That's the main thing. X-axis pe I'm going to measure the time. X-axis usually called the independent axis. So time to chalta rahega na, like regardless of what you're doing, time always passes by. It is independent of everything. So usually time is taken on the x-axis. Even when you do physics, time is usually on the x-axis. And y-axis pe I'm going to measure the temperature. Okay, so basically starts off at 0. So at 0 seconds, what is the temperature? Like when I'm starting off the experiment. Then 5 seconds ke baad ya 5 minutes ke baad, what is the temperature? 10 minutes ke baad, what is the temperature? 15 minutes ke baad, what is the temperature? I'll keep constantly plotting it. Okay, so that's what this graph is representing. This I want.
Will we draw any of them in this class?
Any of them, matlab?
Draw a couple of graphs.
Yeah.
Hey,
What is your question, Neil?
will we be drawing graphs today? Because like I generally never drawing graphs.
Or just one graph?
Okay.
That's this one. Okay. So before you draw, like just pay attention here. Let's discuss this concept first and then you can start drawing. Okay. At time equal to 0, let's say this I start off like -5 is here, then 0, and then 5, and then keeps going on. Don't worry about the scale right now because I don't have enough space to just get the idea of it. At time equal to 0, initially it's at -5. Let's change the color. Yeah,
Is it necessary to put minus?
I took minus because melting point of ice is 0. So, okay, now, oh, I forgot to add one more thing. Stick a thermometer in this because you want to keep measuring the temperature at certain intervals of time, or just keep observing the thermometer to check what is the temperature. So started off at -5 because that is the temperature at which I took the ice. I started heating this. As time passes, what do you think will happen? Will
The
temperature
temperature will increase because the intermolecular forces are weakening, so the temperature will increase.
Yes. Now, what do you expect the temperature increase to be? Will it be constant pura aise jayega? Or thoda
Will it
increase
keep
okay?
changing?
Will it go like that? Like how
The
exactly?
second line. But will it keep like increasing and increasing? So not like it'll keep like changing slightly. Like it'll
That's
go from
not true.
5 to 6 to 7 to 8. Maybe not.
That like decreasing nahi hoga. So it will constantly increase up to a certain point. Then that point is when it hits the melting point. Okay. So ice hai, -5 it's ice, -4 it'll be ice, -3 it'll be ice, -2 it'll be ice, -1 it'll be ice.
Once it hits positive, it'll start melting.
Yeah, once it hits 0, it'll start melting. So when it is melting, it has been observed कि उसका temperature increase नहीं हो रहा है. So as long as ice is melting, it will remain constant. Horizontal हो जाएगा ये line. Okay.
Time bar, ma'am.
Huh?
What should be the unit put in the time bar?
Time, it depends on how quickly, like it can be minute, it can be second. Scale will
That be ours.
Yeah, that won't be asked. So when you
No, like if you have a huge block of ice, something that will take hours.
yeah, ours, absolutely.
But
So
then
it
we have to take an
depends.
so over here I can assume any time.
Yeah, it depends on the context. Who is doing it? How are you doing experiment?
So like what would you estimate? Because I'm like
Miss, considering the drawing which you made on the corner, I would say minutes.
Minutes, yeah.
no, but so 1 minute Okay.
More, 2 or 3.
What
But
unit would you put
scale
there?
and all, it depends, Neil. Like that, you don't have to worry about unless until you're like sitting doing experiment and capturing the values. Here, I want you guys to focus on the concept, the idea ki kya ho raha hai is situation mein. Because this is true for every single thing in the universe. When you sit down and plot this sort of a graph, the temperature time graph, right from its solid state, उसका temperature पहले increase होगा until it hits the melting point. When it is melting, temperature always remains constant. Once all of the ice has melted into water, then it will start increasing again. Yeah, Sahil, what's up?
But like, does this happen only till liquid, this graph, or is it till it becomes gaseous?
Till it becomes gaseous, we'll like do the whole thing. Yeah. So when it is in liquid state, it's going to increase again until the liquid starts boiling. Once it hits the boiling point, same thing as here, it's going to remain constant. And once all of the water has boiled, let's say like this is trapped, like put a lid on it so that we still have all the water within the beaker itself. And if I still keep constantly heating it, pura steam, like water vapor banne ke baad, and then the temperature will keep increasing. And this will increase as long as you keep heating it.
I have a question.
Yeah, Sahil.
So if this ice you melted and it turns to vapor, but you close it, so it condenses to water again, and the water keeps evaporating. So will the water like ever run out because it keeps condensing on the top?
So whatever water is inside will remain inside. So if you look at any condensation from outside, that would have been due to the water vapor in the atmosphere. So that we don't have to worry about.
No. From the inside, like if it condenses on the top, falls down. So will the water inside it ever end if it keeps condensing and forming water every time it starts to boil?
No, I mean, yeah, I mean, if you maintain ये पूरा beaker के inside का temperature, if you maintain it at 100 degrees Celsius, eventually all of it is going to boil off, turn into water vapor, and then you're still increasing, right? So as long as, see, it all depends on the temperature. Yeah. Yeah,
And
but
one more thing.
yeah.
And if you switch off the like the burning thing, so
Mhm.
won't that thing, the line just slowly come going down and down to
Yeah.
switch off cooling down?
Yes. So this is in the context that as long as you're providing heat energy to that solid, this is the graph, is what the graph is going to look like. You're not disturbing any conditions. You are constantly supplying the heat energy. So as opposed to time, like along with time, because you're also supplying the heat energy, it'll essentially remain the same whether you take time or whether you take energy supplied. Okay, as you keep supplying the energy, you will observe that temperature increases, then remains constant. So let's give it names so that it's easy to refer. Let's call this A, B, C, D, E, and F. So from A to B, what is the state of matter, whatever we took in the beaker?
In the beginning, it was solid.
Solid. And the heat energy is being used to increase the temperature.
Which
You
caused
can
the
make-
solid to become a liquid.
Yes, you can like you can make it into tabular form. It'll be easy. So this is the graph, like graph mein kaun sa region. This is the state of matter that you find in that region, and this is what is the heat energy being used for. So A to B के बीच में you will find that it's going to be solid and the heat energy is being used to increase the temperature. Like whatever heat you're supplying, उसके basis पे इसका temperature increase हो रहा है A to B.
So we need to write this down now.
I'll give you guys time. Like let's finish off the discussion, then you can write it down. Then B to C. What is happening from B to C? What will be the state of
From liquid it become gas.
huh?
Ma'am, it's still
From
liquid.
solid है.
Until all the ice melts, it's still liquid.
It will become liquid. From B to C it will become liquid.
Yes. So if you observe the beaker, यहाँ पे अभी melt हो रहा है. So you will find solid plus liquid. Partly solid, partly liquid. क्योंकि there is melting taking place.
And heat energy will still keep increasing.
Heat energy, yes, but what is that energy being used for? Is it used for increasing the temperature?
Maybe maintaining the temperature.
It is used to break the bonds, break the intermolecular forces. Like the heat energy is used in the conversion. Like none of the heat energy is used in increasing the temperature. इसलिए from B to C it's a horizontal line. Like is time pe whenever you measure the temperature it's the same, it's at 0 degrees only or whatever is the melting point only, because कोई temperature change नहीं हो रहा है from that heat energy. Whatever energy is being absorbed by the ice, all of it is used in conversion from solid to liquid. It's used in phase change. So conversion is one word you can use, or you can also say that there is phase change. Yeah. Then C to D. State of matter क्या है C to D?
C to D is liquid to gas.
अरे साहिल, follow carefully. Like A to B solid था, B to C melt हुआ. Melt होने के बाद 0 degrees पे ही gas बनना चालू हो जाएगा क्या?
No increase in temperature. So it will maintain liquid, but it will be increasing temperature.
So from C to D, ये पूरा duration के लिए state will be liquid. Somebody had said liquid. You're right. And what is the heat energy used for in this duration, C to D?
To ensure that the liquid becomes gas.
Again, Sahil.
Ma'am, increase in temperature till 100 degrees Celsius.
Yes. You will start thinking of gas only once it hits the boiling point. तब तक no question of gas at all. उसके पास इतना energy नहीं है. So during this time, again, whatever heat energy you're providing is being used to increase the temperature. Once that temperature hits 100 degrees, फिर से what's happening? D to E.
Ma'am, water vapor.
मतलब water vapor exist कर रहा है, water vapor बन रहा है. Like what is that called? Use the correct words.
Ma'am, vaporization.
Vaporization or boiling. The state, फिर state of matter क्या देखोगे? If you look inside the beaker, what all will you find? Solid, liquid, gas में.
Ma'am, gaseous state.
Only gas?
Liquid and gas.
Partly
Liquid and gas. Yes, part gas, part liquid. How liquid plus gas? Like, have you guys seen boiling water?
Yeah.
What does it look like?
Steam.
No, like when you're boiling water in a vessel, exactly what do you see उसमें like vessel के अंदर?
The water is like having bubble, which is then slowly, then the quantity is reducing.
Correct. So you have water. Water के बीच में you also see like big bubbles which rise up to the surface, right? So bubbles are basically trapped air or gas in water, and क्योंकि ये boil हो रहा है, bubbles essentially contain water vapor, and because they're lighter, less density come here, so they rise up and they escape off into the atmosphere. So liquid be here and gas in the form of these bubbles. That's what liquid plus gas. And what is heat energy used for during D2E?
Ma'am, the heat energy will like a phase change conversion. Like
Yes.
it's constant.
Yes. So temperature के लिए use नहीं हो रहा है. It is used in phase change, or it is used in boiling. Boil करने के लिए use हो रहा है. Or you can say all this heat energy is going into conversion. Conversion मतलब क्या? Basically, you're just breaking those bonds and increasing the spaces. So liquid is turning into a gas. And finally, like इसके नीचे, just continue. E2F. What is the state of matter over here?
Oh, vapor.
In D2E,
E2F. D2E खत्म हो गया. E2F.
now entirely gaseous.
Entirely gaseous. Yes, only gas. And the heat energy is being used to nothing. मतलब क्या हो रहा है एनर्जी को? कुछ नहीं हो रहा
Temp
है.
increase.
Increase the temperature. Yes. Okay. Note this down. Try to understand. Try to like fill this on your own by looking at the graph. अगर नहीं आ रहा है, or if you're not getting the right words, then look at the board and do it. Okay. So this you should intuitively get it. You should be able to understand and read the graph easily.
Excuse me, ma'am. I have a graph book. So shall I do the graph in that?
Not necessary, because the concept here is not presentation of the graph. It is more to understand the graph. So तुम्हारे notebook में ही just take a scale pencil, draw the axis, and the shape is what is more important. See that यहाँ पे horizontal lines है. All right. So B to C, this is at melting point. And D to E, ये जो
In every
temperature है, this is at boiling point.
in every case, it is temperature only, no increase except for like phasing, changing.
Yeah, because y-axis पे temperature measure कर रहा है ना, तो यहाँ पे अगर ऊपर जा रहा है, ऊपर की तरफ, basically temperature is the one that's increasing. You don't have to write the numbers also, because I took ice as an example. 0 के नीचे होना चाहिए. But if at all we took like wax or something, your temperature numbers will change depending on what you take. But one thing is important, that first horizontal line you will find at the melting point of that substance, and the second one, क्योंकि liquid बन गया, so this will be at the boiling point. This
What will we do if we have something that is not very easy to melt, like something that takes hours and hours on end to melt, and like extremely high temperature, like above
Metal.
100 degrees?
Yeah, so you don't do the experiment with that.
No, like how if you have to, and it's like some kind of project or something like that, where you have to melt something very high, like let's say some metal, and you have to draw a graph chart like, to show that this is the increase in the temp. How will you show that? Because then what will be the beginning value?
Yeah, the beginning value, it depends on when you start off. See, all of this remains the same.
Room
Take
temperature.
the number and how steep this is. Like, is it going to look like this, or is it going to look like this? Like, basically the angles change, the height changes, but basically पहले increase हो, but one concept, पहले increase होगा, फिर constant होगा, फिर increase होगा, फिर constant होगा. That remains the same for everything.
So basically, the temperature is what decides how the lines are going to be like. So if sometimes it is just directly increasing, so you just draw like half an X.
Yeah. It depends on the material कि कितना easily melt होगा, कितना easily boil होगा, angles कैसे रहेंगे, all of that.
And one last question.
Hmm.
If we have to increase this graph, increase it horizontally or vertically?
Increase
Like if you have drawn like this only graph, but the thing is you are melting something, but something is wrong and it's only staying at room temperature. So you need to keep, it goes all the way up. So you heat it up, then it goes to 100 degrees Celsius, and then it just cools down all of a sudden, even though the heat is on, something like that happens. And you need to still continue it. So when will you exempt it like straight or to the side?
that in that case, then you'll see what is going wrong, because ideally that should not happen. If you're providing energy, see, energy is always conserved. Okay, it's just like matter, you cannot create or destroy energy. So अगर if you're giving it heat energy लेकिन इसका temperature increase नहीं हो रहा है या इसका phase change नहीं हो रहा है, you need to figure out कि वो energy कहाँ जा रहा है. It means that something else has caught on fire and that's taking up all the heat energy. So then you need to go back to your experiment and see what's going wrong there. But ideally, if you do everything right, this is what the graph basically looks like.
I'm done.
Okay.
I'm almost done. Give me 2 minutes.
Yeah. Don't worry. So the kind of questions you'll be asked based on this concept is, you won't be asked to draw the graph. You'll be given this particular graph, like for example, butter ke liye or wax ke liye or petroleum jelly or something like that. You'll be given the graph, and then you'll be asked, okay, what is the phase of matter you will find between the points C to D? Or you'll be asked something like, define the phase change occurring at D to E. Then you need to know correctly ki, okay, is point pe the phase change is boiling, so you need to write the definition of boiling. So that's the kind of questions you'll be asked. Or you'll be asked, look at the graph and answer, what is the boiling point of that substance. Then graph mein you need to plot ki, okay, is temperature pe boiling ho raha hai, matlab, okay, what is this temperature corresponding to, that way. All right. Roshmit and Jaydeep, Alisa are writing. Neve is done. Neil, Jay,
I'm
Kushagra,
done.
Kyle is done.
Done, ma'am.
Even I'm done.
I'm done as well.
All right. Kushagra?
I've done.
Oh wait, actually I missed something. Just give me 2 minutes.
Okay. Okay. Where you guys at, Roshmit and Jyoti? Which one are you?
I'm almost done. I'm writing the graph cards.
And I'm almost
Tabular format. I'm just going.
Okay. नहीं टेबल लाइक अभी स्टार्ट कर रहे हो कि कौन से लाइन पे हो, कहाँ पे हो?
I'm almost done. Last two.
ठीक है. Okay, Rashmit seems to be done.
I'm also done.
Huh? Cool. All right. Now coming to the next part. Okay, so energy supplied also follows the same format, right? Like as time goes by, मतलब कितना energy supply कर रहे हैं. Initially जब हम energy supply कर रहे हैं तो that energy is going into increasing the temperature. The next part, we don't see any increase in temperature. Okay. Are you guys aware of these laws? Law of conservation of matter, law of conservation of energy. 6th, 7th grade में पढ़ा था क्या? Yeah?
I don't remember.
Don't remember?
I don't.
Yeah. So
I can
this
check my
is,
text.
so this is like a truth of the universe कि energy is conserved. Yeah, energy in the total universe, if you calculate it, जहाँ पे like when the Big Bang occurred, even now, even in the future, the total amount of energy will always, it is always the same. Okay, so basically conserved का मतलब energy is neither created nor destroyed.
Ma'am, but energy can be converted into matter.
But that's a different thing.
Energy can be converted into matter, matter can be converted to energy, but practical level pe, that's the stuff that goes on in stars and black holes and everything. So on Earth, you can't like,
Yes, ma'am. So then how, if we go on a very minute level in physics, then how will remain the same? Because हो ही रहा है, बने एक जूल भी एनर्जी बढ़ गया, फिर भी.
so that's why you have law of conservation of matter also, you have law of conservation of energy also. So again, those are like that relates to quantum physics and those are extreme cases, and that's why Einstein was such a big deal, because he was the one who gave the relation between matter and energy, E equal to mc square basically.
MC square.
Yeah, so
Like a small amount of mass and large amount of energy, large amount of energy, small amount of mass. And
yes,
that's why we can't go at the speed of light. So all of that
yeah,
is now that's theoretical physics, but still meaning. Then is
So,
it so?
but on Earth, whenever you're doing any experiment, whatever you're doing, like if you're not disturbing quantum states, as long as you're not going down to the particulate nature, electrons, protons, neutrons.
Okay, then this is applicable.
This thing, yes, energy
Because
is
like जो
not
जो
destroyed.
like इतने न्यूक्लियर बॉम्ब्स टेस्ट किए हैं तो
Yeah.
वो एनर्जी कहीं नहीं थी. That energy is still there, but it did not used to be there. It used to be in the form of a small
It used to
radioactive
be in
element.
the form of matter. Yes, that's matter energy conversion. But end of the day, everything is conserved. It's not being created out of thin air. So that's what this law states. It is neither created nor destroyed. It is just transformed into one form to another. Do you guys know what are the different forms of energy?
Yes, like we have run quite a few.
Yeah, give me the examples.
Potential, we have potential energy and kinetic energy, heat, thermal energy, electrostatic.
Electrostatic, nahi, electrical energy.
That's force. That's force. Electrical energy.
Yeah, electrical energy.
Hydrogen
sound
energy,
light
solar energy.
heat energy, right? So even when you're switching on a light is a form of energy, but it is not being created. It's the electrical energy which is getting converted into light energy. So that's like a known fact in science, in physics, in chemistry. Key energy is conserved, it's not created or destroyed. So when you go back to our state change, if we can't, so initially, like when people did the experiment, obviously, like it was not theorized, like people knew of particles of matter, but it's not like very obvious ki, okay, phase change may use ho raha hai energy. So when they saw the thermometer, they were like, ठीक है, हम heat energy दे रहे, temperature increase हो रहा है, makes sense. Whatever energy we're giving, we can see where it is being used. But when it reached melting, people couldn't see the change in temperature. But law of conservation of energy. So where is that energy going? So that's how they figured, okay, energy is required for this phase change, for this conversion. And that particular energy, which is used in phase change, because it's not very obvious, you can't see it as a change in temperature, they gave it a name, latent energy or latent heat.
Okay. Can you just take it to the last slide for just a moment, ma'am?
Yeah.
Just a minute. Yes, ma'am. Done.
Yeah. So they called it latent heat. The reason why it is called latent heat is the word latent, its roots, I don't know, Latin, Greek, wherever it's taken from, it means hidden. Because you can't see it as heat energy quite obviously, because temperature increase nahi ho raha hai us energy ki wajah se, to call it latent heat. So depending on which phase change is taking place, there are two latent heats that we refer to. One is latent heat of fusion, and the second is latent heat of vaporization. Okay, so again, it is the heat energy used up in melting or boiling, right? So if I have to phrase this in another way, it's basically the heat energy that is required to convert a certain mass of a solid into liquid, if you're talking about latent heat of fusion. And it is the heat energy required to convert a certain mass of liquid into gas when we're talking about vaporization.
So for vaporization, it is solid to liquid.
हाँ, vaporization क्या होता है?
No, sorry, liquid to gas.
Yeah.
And for fusion, it is solid to liquid.
Yes.
Then shouldn't that just be called melting, not fusion? Because isn't fusion mean the combining of two things? Or no more things.
So
Like
colloquially,
if you use
again, there's like tiny bit of differences, right? So when we say vaporization, it's conversion from liquid to gas. Liquid to gas conversion, evaporation may be hota hai, boiling may be hota hai. So you don't want to like pigeonhole it into like just one process. This is for overall solid being converted to liquid. That's why you use like these kinds of terms. Okay. So formal definitions, I'll just open the chapter notes so you can just write it down from there.
I mean, we have the books, we can write from that.
Oh yeah, if all of you have it, absolutely. I'll tell you exactly what to write. So latent heat of fusion. Fusion is for solid to liquid change. Definition के लिए write down the point 2. So latent heat of fusion or melting of a solid is the quantity of heat in joules. So joules is the unit for heat, like the way you use meters, inches, all of that for length. The way you measure quantity of energy is in joules. Calories, joules, all of that. Required to convert 1 kilogram of the solid at its melting point to liquid without any change in temperature. So that quantity of heat is called latent heat of fusion. So this is an example. If you're talking about liquid ice, latent heat of fusion is this much, 3.34 into 10 raised to the power 5 joules. One tiny correction in your book, guys. When you write joules, always put capital J, small j nahi hona chahiye.
Okay.
Joule is the name of a scientist who did work on like energy
And then,
and all.
isn't joules another word for voltage or something? In physics, I think.
Voltage is its own thing. Joules is for energy. So if you're talking about electrical energy, again, you use the same unit, which is joules. Whenever you come across joules, just make it capital J. Scientist के name हमेशा capital में होता है units.
Okay.
So vaporization, if you see, it is the same thing. Yeah, note down vaporization also. This is the thing. So latent heat of vaporization of a liquid. Sentence is the exact same, just that solid becomes liquid, liquid becomes gas as well. Quantity of heat in joules required to convert 1 kilogram of liquid at its boiling point to vapor or gas without any change in temperature. So these values for ice, you don't have to memorize them. In case you are given questions about this, you'll be given that. The latent heat of fusion for ice is this much, then calculate how much energy is required and all that. So you don't have to memorize this. Just know the concept. Kyle got disconnected. Neil, Jayat, Kushagra, and Vesha, let me know when you guys are finished writing.
Done.
Done, ma'am.
Okay.
Just a minute, I'm almost done.
Done.
Yeah, I can see Neil like stop writing. Ali's also is finished, I think. Sare concepts, is it clear? Any questions, any doubts you guys have?
No, ma'am.
No questions or not clear?
No question.
Okay. We're almost at the end of the chapter. It's just like two more small concepts. We talk about pressure, effect of pressure, and the difference between evaporation and boiling. Give me that.
Just a minute, ma'am. I'm almost done.
Rashmit, you finished writing or still writing?
Yeah, I'm done.
Okay. Kushagra and Anvesha, what about you guys?
Yes, I'm done. I had mentioned that I was done
I'm almost
actually
done.
earlier.
Okay. Cool. So that's latent heat. You need to know what is latent heat so that in case you get numericals, you will be able to answer it. But more importantly, like the more popular question is just identifying latent heat kya hota hai or asking the definition. More chances of those sort of questions you'll get based on this. Need to know what it is. And effect of change in temperature is where we started off. Kinetic energy of the particle
A
increases.
minute, ma'am. Can you make sure? Okay, yeah.
So due to increase in kinetic energy, they start vibrating with greater speed. So greater motion, matlab, like it's a different phase of matter. That's the difference between solid, liquid, gas. That is the thing. Temperature. Oh yeah, this is important. How familiar are you guys with the different scales of temperature? Fahrenheit, Celsius, Kelvin.
Yeah, we have done all of them last year.
Yes. Okay. So you guys are comfortable, familiar, conversion, pata hai. Can you guys tell me in Kelvin what is the boiling point of water and melting point of water? Send it on chat. Because send it on private chat to me because I want answers from all of you.
What is the melting point of water, right?
So melting point of water is 0 degrees Celsius, right? And boiling point is 100 degrees Celsius. I want these values in Kelvin. So calculate it and send ki Kelvin mein kya hoga. Because from now, if at all we are doing any temperature related things, right? So we'll start using Kelvin a lot, especially when you get to grade 11. It's like you'll automatically be referencing Kelvin values. So it's good to be familiar. Okay, what is high temperature, low temperature, and all these three scales. Yeah. Neil has already sent. Very nice, good. Rashmit, is that boiling point or melting point, the one you sent?
That's melting point.
ठीक है, awesome. Neve has sent. Neve, boiling point calculate करके बता ना. That is the formula I know, but Jay, it's slightly wrong. Don't approximate. Give me the exact value.
Okay, ma'am.
अगर decimals round off किया तो no issues, no problem. But don't like if it is. Don't completely round it off. Don't go too far away. हाँ, ठीक है. Jayad, now you sent it. Alisa, yes. Oh, check which is boiling, which is melting. Jaydeep, yes, absolutely. Melting correct, boiling correct. ठीक है. Who's Rashmit sent, Jaydeep sent, Elisa sent, Neve sent. Neve, okay, yeah, you sent both. Rashmit, you haven't sent boiling point yet. Jayad sent. Kushagra, have you sent? नहीं मिला. तो Kushagra and Anvesha.
Yes, ma'am, I'm sending.
हाँ, these are corrected. Okay. Rashmit, yes, that is the boiling point. ठीक है, सही है. क्या हुआ? It should be simple. Where are you? What are you doing, Kushagra? Anvesha, close enough? Yes, I'll take that. What are you doing, Kushagra? Why are you taking so much time?
I'm typing.
Typing? Okay. Okay, it's already 4:35 now. Should end the class. Okay, we'll finish off the chapters. The rest of the thing is going
Just a minute, ma'am. Just a minute.
Sahil missed out the last bit of it. क्या हुआ? शाकरे इतना टाइम तो नहीं होना चाहिए.
Sorry, ma'am. I was just drawing the table of all conversions. So I took it down.
It's okay. Already chapter notes में है ना, and like that you can do later. ठीक है.
Like the
तो आ
moment you
गया.
write the practice, you get.
Okay, so now we'll end the session here. The rest of the things will take maximum an hour. It won't take more than that. So we'll get to do some classes also.